So this is today. I'm just planning to demonstrate machine learning projects. I'm going to make a lot more of these. I've been putting it in all my classes, and I've added several new ones, and I'm going to keep them coming because I think this is enormously important, and I'm going to be teaching it in all my workshops over the summer. Um, anyway, then we'll have a few more chapters in the book, and the last class on hacking APIs. We're near the end of this class. There's just 4 more classes that have material, and then just the final exam. And you'll find a chart in Canvas showing how many points you get to need various grades so you can predict your future and make a plan to earn whatever grade you care about if you're worried about grades, which a lot of students are. So all I want to do today is show you the machine learning projects. And all right, so I put them in various places, but the most up-to-date list is right on my home page right at the top here. Machine learning projects, the ones inside the classes often don't have all the latest ones like the one I just wrote today. So I'm planning to demonstrate these, but let me start with a few introductory slides just to explain why I think this is so important. And I'm going to be giving a talk at RSA, and this is the first early part of what slides I'll use there. Although just like here, it'll mostly be demos, but I have a few slides. So this is why there is an emergency. From this Ars Technica article, there is a graph, and what this shows is the size of the model in machine learning in terms of parameters, the number of parameters that are used, which is a measure of how strong the machine language model is. And notice it was 0.1 in billion in this year, and then it was 1 billion the next year, and 10 billion, and 100 billion, and 1,000 billion year after year. It is growing by more than a factor of 10 per year. And Moore's law, which is normal computers, have been growing for about 50 years at the rate of doubling every 18 months. That was seen as revolutionary. It changed the world. It made it so that all of us could not just learn what our parents did and do that for a living. Everybody has to be a part-time student for their whole life because that insanely rapid pace of learning causes everybody to be stressed. Everybody is constantly flooded with new versions of everything, new devices, and you can't escape it. And that's Moore's law. And artificial intelligence is growing much, much faster than Moore's law. So the explosive growth of this AI is the reason why I'm doing this, why I said this is an emergency. AI is the most important thing to learn. This kind of growth rate means that it is going to be in everything within a year. And if you don't learn this, you're going to be worse off than somebody that didn't know how to use the internet in like 2010 or 2015. Because it's going to be all around you. And the other thing I'd like to say is if you haven't actually done it, you haven't actually coded AI, you don't understand it. And there's plenty of good evidence of that. And here's the Gartner Hype Cycle, which is good, clean fun. Let me just zoom into this for people that aren't familiar with this. This is Gartner has this famous document. And here, let me go a little bit smaller first. The general point of this curve is all technology goes through a period of ridiculous fast growth and inflated expectations, so everybody thinks it's the greatest thing in the world. Then you have the trough of disillusionment. So here's the innovation triggers. You have a new thing, and it starts explosively growing. Then you have the peak of inflated expectations, where everybody thinks it's going to be worth an incredible amount of money. Then there's disillusionment, when they discover the defects of it, and everybody hates it, and everybody says it's terrible. And then you gradually discover it's in between. It has some value, and it reaches some steady state. And here's I'm going to zoom in more to see this. Here's a chart. This chart is from 2022, last year. So last year, you see they had things here like AI, machine learning code generation, which is what ChatGPT did, was way down here in its infancy, far less mature and important than the metaverse. This was last year. And digital humans are way up here, and Web3 is way up here, just hitting the peak. So I think this is more or less accurate. And NFTs were already collapsing. And I think this is fair. In the last year, we've seen NFTs totally collapse. We've seen Web3 go over the top and pretty much collapse. But what has happened is AI, which was nowhere, is now way above the metaverse. The metaverse has already collapsed. And AI is way up here, rising fast. And it's going to come up more. So that's why I think it's really important. And this is a very nice chart. I think it's very much the way things really are. Everything in technology goes through these stages. And so right now, there's an incredible amount of hype and nonsense about AI from people who really should know better, like Google. 60 Minutes, a couple days ago, had an hour-long interview with Sundar Pichai, the CEO of Google, and ridiculous nonsense was spewed. For example, one thing they said on that thing was that Google's chatbot learned a language it had never seen before, and when somebody asked questions in a language it had never seen before, it taught itself that language and answered in that language. Now that is impossible. A human can't do that. If you walk up to a human and speak to them in a language they've never heard, they can't figure it out. Nobody can figure it out, and AIs can't figure it out. The article I read on the Daily Beast said what really happened here is Google's chatbot is based on an earlier AI model, which was originally taught in Pakistani. So Google didn't teach it the Pakistani language, but the earlier training included that. All right. Anyway, and Elon Musk has been warning for years that AI is going to cause civilization destruction, which is the kind of thing where they're thinking about these intelligent robots. And this is just crazy hype stuff. All right, Rouhani, I'll take a look at that after the lecture. Anyway, this is the nonsense you have out there. Anyway, AI is not the same thing as machine learning. AI is artificial intelligence, which are computers that emulate what humans do. And that could get up to these ones that actually try to have a human personality or something. Machine learning is a subset of AI, and that's all I'm talking about. Machine learning is technology that identifies patterns and makes decisions and improves itself through training. And this is the stuff that is currently being used. This is what ChatGPT is. It's very effective, and we'll see whether we ever get AI that passes for humans. Yeah. Well, let's talk about, for AI is the general container. Let's talk about machine learning. In machine learning, you have to feed in some inputs. Like, for example, when you train ChatGPT, it learns how to predict words, so you have to give it a body of words to examine, like all of Reddit, this kind of thing, or you give it a bunch of images to sort them. So you have to feed in inputs. And when you have an AI or machine learning driving a car, then it would have access to, say, the cameras and the LiDAR and stuff. And I think that's what Teslas are. Teslas have machine learning driving a car, and they have trained it on a bunch of test drives to recognize things. So the input, they all have input just like we do, input from their senses, essentially. If they do any, that's their input. They have some kind of input. Now, the ones we're going to do just have a set of fixed files as input, but you could have one that you connect to a real camera and it looks at real objects for input.
How are they going to get the sensory input to create, the artificial humans or something like that?
Well, people say that they might be able to make artificial humans by building a robot with eyes and ears and stuff. I mean, there's no reason you couldn't. A Tesla essentially is that. Tesla has like cameras, and it's able to like distinguish objects in the road enough to drive. So you could just have a robot with, cameras and microphones on it, and in principle, it could learn to react to that stuff. And I think we will have them pretty soon.
Yeah.
But
I guess my confusion is, how can they go and distinguish all of the different sensory inputs? Like when we're sitting here in the room, there's like the whir of the projector, and we're kind of ignoring a lot of extraneous noise, sensory noise, so to speak.
Yeah, that's absolutely true. And that is the hard part, and that's why there's all these Tesla videos where it fails. If you're driving down the road and you see something unusual, then the Tesla AI often does not correctly understand what it is, because it has only learned to recognize certain objects, and when it sees something new, it doesn't know what it is. And of course, humans can make that mistake too, where they see something and misunderstand it. So I mean, that's, but it's absolutely, what's that?
And they freeze too.
That's right. So I mean, and it's absolutely true that it will have limitations and it will have to learn things. And when confronted with new things, it will not know how to sort it. Like I say, if you speak a language, an AI doesn't know to a language AI, it will not be able to figure out what you're saying and predict the next word correctly. It has to be trained for the environment it's in. Of course, you could say the same thing of humans. Yeah. All right. Anyway, so, all right. So anyway, let's take a look at a few of these projects, and I'm going to break these up into separate videos so I can attach it to the projects, because I think I've learned how to do these a little better than I did in the first time. So I'll demonstrate a few of these. I'm going to stop this video.